One thing I wanted also to add is a wet map that will be applied onto the ground. So let's make a quick network box here. I mean, a quick, it's just a really compressed notion, but you'll see what I mean by quick. So what I want to do is import our, let's make it here somewhere underneath. It's closer to our baked little guy. So let's make a grid here. I really want to make a wet map, which will apply as a mask. Let's make it blue. Let's make a grid here. Yeah. So I'm going to use the same parameters as I did before. It's going to be a 1.2 by 3.4 meter grid. Yeah, a lot of segments, which will define. I'll bake the color into the mesh here. There's a lot of methods to do this, but I'm going to use this one for now, and we'll transform it. Let's transform it, kind of like yeah, I'll offset it like this. So basically, it just covers the whole area. So the wet map will be happening here. If you see the side view, it just falls onto the ground and has a contact with the creature. Let's make a UV texture. You can use UV texture or UV project. It's going to be a point attribute. So we have the UVs here. Now let's set the color to black, because we're going to work with color here. Color black. So we have this symbiote here, and he's white, which is great. It's already half done. Let's time shift this input. I want to really use the frame 1. So the frame 1 will be working on a noise texture, which will be covering this symbiote. Let's make an attribute block. Use a really simple noise inside of it. Turbulent noise this time, and we'll fit it. Color, value, position. So let's make it maybe. Let's actually expose all the parameters. Let's go into the VFX swap options, create input parameters, and expose all of those guys. And for this guy, I'll expose the source min and source max. So let's set the frequency 25 to 25. It's going to be a noisy texture, basically covering the whole thing. And for the offset, I'll set the time. So it's going to offset in time. The amplitude will be 1, roughness maybe 0.75, something like this. And yeah, so it basically moves along this whole thing. Yeah, and we'll remap these values, make them a little bit more contrasty, something like this. Yeah. All right, and then we'll just attribute copy to the moving version of the monster. So the texture transfer properly, and it's really fast to evaluate. Here, let's do the magic, which is going to happen in the solver node. And the first input we put the ground, because this is the receiving part of the process. The ground is going to receive the color. So let's go into the solver here. The output is set to the previous frame. So if you don't know, the solver is a really special kind of node. It's a DOP network actually, which contains the inputs and the previous frame of all of the inputs. So you can sample the previous frame to get information from the past, and this is amazing. Basically, it lets you control time, and it's really confusing, usually. So in the first input we have the ground, and the second we have the monster. So let's attribute transfer this guy. We want to attribute transfer the color from the monster to the ground. So you can see already stuff happening here, which is weird. We don't want to see this. It's really crazy. But yeah, we'll set the conditions a little bit differently. Kernel size to 0.001, sample count to 4, let's say 5, and distance threshold is going to be really low. The blend width, it's like a blur around the edges. So if you scroll, you'll see that stuff happens. But let's connect it to the output here. So you see there's some kind of contact there. But the mesh is really dense, so it's really difficult to see. But that's okay. Well, we may change that. Let's set the color here, CD, just to be specific. So yeah, you see that stuff is happening here. But because we're using live attributes from this point in time and not from the past, we're not considering anything that's happening in the past. We're just, it's like a regular attribute transfer in the sub level. In order to make it work and remember what happened in the past and leave a trail behind, we need to make an attribute VOP here and compute the maximum value between the two attribute VOP. And in the first one we have this the attribute transfer, and the second one we have the previous frame. So let's dig in, not that far, and let's import two attributes. And why am I doing this import point attribute and not bind? Because the bind doesn't have anything related to the input that you're choosing. If I want to choose the input 2 and I want to bind, like import an attribute from the input 2, I cannot do it with the bind. So import point attribute. Let's set it to first, and this is going to be like a vector because we have vector 3. Let's set color here. Okay, and first input, this one's going to be second input. So the first input will be import now. This one is going to be import previous. So this is going to be import previous, sampling the color from the previous frame, and this is going to sample the color from the current time. And let's calculate the max value and keep the max value between these two connected to the color. And let's see what happens here. Yeah, so while we're in the solver, it's not going to work. So we have to go back here, reset the simulation. And you can see that it leaves a trail because it remembers what happened in the previous frame. So there's a few things that we need to fix here. The trail is happening, but we have some stepping happening here because, you know, we actually should use the interpolated geometry for this. So let's copy this time warp. So I don't want to pull a cable out from there. So let's put it here somewhere. Connect these guys here. So we'll use the sub-stepping from the solver. So let's call it Wetmap solver. And yeah, so we'll use the sub-steps here. So the one will set like 5 and calculate this thing. But also I want in the attribute VOP, I really want the previous CD attribute to fade out, like really slowly fade out in time. So let's multiply it. So every time there's at each frame, we'll multiply the previous color attribute by like a constant, which will be really close to 1, but not really 1. This will allow us to decrease the intensity of the color attribute over time. So let's set it to 0.95 just so you see what happens there. And let's play. And once the trail is left, like if you look closely here, the color fades slowly and becomes black. So it will disappear over time, but it's disappearing quite fast. So, and you have the more intense color here when there's a new contact happening, but the rest is disappearing. So that's cool. So let's go back, reset the simulation, and maybe let's set this guy to something like 0.98 or something like this. 97, let's say. So that's cool. And press the out. Now we have a geometry with color, which is dynamically changing from frame to frame. And let's attribute blur this guy. And instead of the P, we'll just attribute blur the CD. Decrease the step size also. And yeah, that's cool. And let's save this guy with a file cache. So basically we'll save the sequence. Sim wetmap, v01, sim wetmap. and that's cool. Let's set some sub-steps here, like four, let's say four. 4 is enough. And simulate this guy, see what happens. Yeah, so in the next lesson, we will take this Wetmap sequence and we'll bake it into an image sequence. And then when it's done, we will use that image sequence, to drive a change in the specularity of the material, of the ground, in order to show up as a Wetmap, as a more reflective surface. So I'll simulate this and yeah, come back to you. But first I'll make a V1 of the render, and we'll see what happens with the motion blur and those refraction issues that we have. See you in the next one.